everyone, welcome back to our YouTube channel Gurmantra Shiksha Ka Granth. I am your educator Nidhi Dua and I warmly welcomes you at this platform. So guys, in previous lecture we have started the topic thermodynamics and we have covered two parts of this topic. And now we are going to study about the part 3 of thermodynamics. Before starting this topic, today's lecture, I would like to tell you about the syllabus that we have covered till now. As you can see here on the screen, these are the topics that we have covered till now. So without any further delay, let's get started our today's topic. So first topic is our work done during the different processes. As you can see here, we are going to define the work done for two processes. Number one is irreversible process and number two is reversible process. In reversible process, we will discuss the during reversible isothermal process. But first of all, in irreversible process, work done is equals to minus P external into delta V. This is the formula to calculate work in case of irreversible process. While in case of reversible process, work done is equals to P dV minus P dV, where the limit of P will be from V1 to V2. If we talk about the during reversible isothermal process, work done will be equals to minus 2.303 nRT log V2 upon V1, while in case of pressure, W is equals to minus 2.303 nRT log 10 P2 upon P1. What is V2 and V1? V2 is your final volume while V1 is your initial volume. In case of P2 and P1, P2 is your final pressure and P1 is your initial pressure. So these are the derived formulas. You only need to memorize the formula. Okay. You don't need to put light on the derivation. Okay. Next topic is spontaneous reaction. What is spontaneous process, or what you can say what do you mean by spontaneity? A process which under some conditions may either take place by itself or take place on the initiation is known as spontaneous process. Okay, the example of spontaneous reaction or processes are heat flows from hot reservoir to cold reservoir. Okay, next example is electricity always flows from high potential to low potential. And also water always flow from higher side to lower side. This is about spontaneous reaction. Now, a spontaneous process is accompanied by the decrease of internal energy or enthalpy. This is very important point, guys. When a spontaneous process occurs, it always tends to decrease its internal energy. Okay, and also the exothermic reactions shows the spontaneous processes. What is exothermic reactions? Exothermic reactions are those reactions in which the heat is liberated. Okay. Now, the first law of thermodynamics has certain limitations. As you have seen, the first law of thermodynamics says energy can neither be created nor be destroyed. It can only transformed from one form to another. Okay, so for this statement, the first law of thermodynamics has limitations. Number one limitation is it puts no restriction on the direction of flow of heat, and this is not in the position to tell that heat energy cannot be completely converted into work. This second statement is very important because from this second statement you will get to know about the second law of thermodynamics. Okay. Now the topic entropy. What is entropy? Entropy is the thermodynamic state quantity which is the measure of randomness. Okay, you can simply say entropy means randomness or the disorder. or you can say a way of measuring the amount of order present or absent in a system. So this is known as entropy, and this entropy is represented by the symbol capital S. And also delta S is equals to S2 minus S1. What is delta S? Delta S is the change in entropy, while S2 and S1 are the final entropy and S1 is your initial entropy. A spontaneous process is accompanied by the increase in entropy. Whenever a spontaneous process occurs in a nature, its randomness always increases, which means delta S will be positive. And if the entropy decreases, then delta S will be negative. Also, if heat is absorbed, then S will be positive, and if heat is evolved, if heat is liberated, then delta S will be negative. Okay. Now a simple formula to calculate the entropy, to calculate the randomness. The simple formula is delta S is equals to Q reversible upon T. This you have to memorize, that if you want to calculate the value of entropy change, then this will be equals to Q reversible upon T. What is Q reversible? Q is your heat supplied to the body and T is your temperature. Okay. Now a very important point, entropy is an extensive and state function. This is very important point. This you have to memorize. Now if you talk about the fusion process, then for fusion, delta S fusion will be equals to the delta H fusion upon T fusion. What is delta H? Delta H is the enthalpy change and T is your temperature. If we talk about the vaporization process, delta S vaporization will be equals to the delta H vaporization upon T vaporization. Okay. And in last, if you talk about the sublimation process, delta S sublimation will be equals to delta H sublimation upon T sublimation. T sublimation is what? T sublimation is your sublimation temperature. Okay. Now a very important point, a very important section of this lecture, that is second law of thermodynamics. So second law of thermodynamics says work can always be converted into heat, but under all the conditions this is not necessary that all the heat will be converted into work. Okay, this is written here, work can always be converted into heat, but conversion of heat into work does not take place under all the conditions. Also you can say it is not possible to convert heat energy completely into work, or whenever a spontaneous process takes place, it is accompanied by the increase in total entropy of the universe. This you have seen earlier. From second law of thermodynamics, you will get to know about that the direction of a given process. So second law of thermodynamics suggests the direction of a given process, and also it is impossible to obtain work by putting a body below to the lowest temperature of the system. Now Gibbs free energy and spontaneity. Guys, this is very important topic. From this topic you will get an numerical problem in exam. Okay, so this is very important topic. For the spontaneity of a reaction, you need two things. What are the two things? These are delta H and delta S. This delta H is your enthalpy change and delta S is your entropy change. So for the spontaneity of a reaction, both delta H and delta S should be considered simultaneously. And when you consider these two factors, enthalpy change and entropy change, in a function, the function that takes both enthalpy and entropy into the account, then this is known as free energy, or you can say Gibbs free energy. This Gibbs free energy is represented by the symbol or the letter capital G, meaning delta G is equals to delta H minus T delta S. Okay, this is very important formula, guys. This you have to remember. What is delta G? Delta G is your Gibbs free energy, delta H is enthalpy change, T is temperature, while delta S is the entropy change. From this formula you will get a question definitely in your exam. Okay, now if delta G is negative, then spontaneous changes occur with the decrease in free energy. If the value of delta G, if the value of Gibbs free energy is negative, then there will be decrease in the free energy, and if the value of delta G is positive, then there will be increase in the free energy, and if the delta G's value is 0, then the system will be in equilibrium condition. Okay, now standard free energy change and equilibrium constant. This is also very important topic and very easy topic. In this topic you have to remember this formula, that is delta G naught is equals to minus 2.303 RT log 10 K. What is delta G naught? Delta G naught is your standard Gibbs free energy and K is your equilibrium constant. You can easily solve the questions from this formula. If in the cell reaction E naught is known, or if E naught is given, then the free energy can be given by this relationship, that is delta G naught is equals to minus N into F into E naught. What is F? F is your Faraday constant. What is N? N is the number of atoms. E naught is standard cell potential, while delta G naught is your Gibbs free energy. Okay, delta G naught is your Gibbs free energy. One second, guys. This is not standard cell potential. Standard cell potential is your E naught, while delta G is Gibbs free energy. Now the third law of thermodynamics. This law is also very important, and the exceptions of third law of thermodynamics is very important. So third law of thermodynamics tells us about the entropy of all pure crystals. The entropy of all pure crystals is taken as 0 at absolute 0 temperature according to the third law of thermodynamics. And the exception for this third law of thermodynamics is crystal of glassy solids and mixture of isotope of chlorines. Okay. Now Joule-Thomson expansion. In this particular slide, what you need to learn is this Joule-Thomson coefficient, that is mu, and mu's value is equals to dt upon dp. What is dt and dp? T is your temperature and P is your pressure. So Joule-Thomson expansion is the phenomenon of producing lowering of temperature when a gas is made to expand adiabatically from region of high pressure into the region of low pressure. Okay. So Joule-Thomson expansion is denoted by the symbol mu, and mu is equals to dt upon dp. Now a very important topic, or you can say from this topic you will get the question, that is inversion temperature. What is inversion temperature? As you know, every gas has a definite value of temperature. When the sign of mu, Joule-Thomson coefficient, changes from negative to positive, then this temperature is termed as inversion temperature. And inversion temperature is equals to 2A upon RB. This formula is very important, guys. This you have to memorize. Okay, Ti, inversion temperature, is equals to 2A upon RB, where A and B are your van der Waals constant. Okay. Now here is a practice question. The question says the enthalpy change from transition of liquid water to steam is 40.8 kilojoule mole inverse at 373 Kelvin. Calculate the delta S for this process. You have to calculate the change in entropy for this process. Okay, so let's see the solution for this question. As you can see here, you have given the value of enthalpy change, and also you have got the value of temperature. So as you know, to calculate the value of entropy change, delta S is equals to delta H upon T. and in the question you have given the value of delta H, that is 40.8 kilojoules. So you can change this kilo into by multiply 1000 and T is equals to 373 Kelvin. When you solve the question, delta S is equals to delta H upon T. When you put up the values in this formula, you will get the correct answer. Okay. Now, in case if you are new here at our YouTube channel, you can like, share and subscribe. And also if you have any query, you can mail us on tanejanehaofficial@gmail.com, or you can also contact us. Now a very important announcement, if you are preparing for CSIR UGC NET, you can follow Neha Taneja ma'am on Unacademy platform. On Unacademy platform, you will get daily life classes, structural courses, live tests and quizzes, and with one subscription, you will get unlimited access. If you are interested, you can go through with this detailed paid classes. After taking the subscription, you can use the referral code NEHA, that is NEHA, and after using this referral code, you will get the 10% discount on total fee. Thank you very much guys. I hope you all like the video.